Okay, so what we are going to do here is we're going to show a series of steps that would give you a recipe to attack most problems that we're going to be studying. And this is a recipe that you can use during most of this class. So let me show you the steps. So what we would have is 3 steps, which are called prepare. And this basically means trying to understand what you're being asked. That is what prepare means. Then solve. This means using the tools, the physics tools, the equations that you know to find the answer. And then assess. What that means is, once you got the answer, does it make sense? Did you get an answer that is meaningful? Those are the 3 steps: prepare, solve, and assess. Of all those steps, this one here, prepare, is the most important because you have to understand what you're being asked, and if you don't understand what you're being asked, you're not going to be able to solve the problem successfully. So what does it entail to prepare a problem? There are many things that you can do. Probably a very important one is drawing a picture of your problem. If you draw a picture, you can visualize the problem in your head, and then you can come up with ideas on how to solve it. Then collecting necessary information, so things that you know, things that you need to find, and then do some preliminary calculation. And what this means is basically you have to know, you have to have an idea of the sort of answers that you're going to get. For instance, if you are calculating the speed of a runner, right, a recreational runner, then you should know that you should be getting something around 6 miles per hour. So that's the type of speeds that you want to be looking at. So that will help you later compare to your answer and see if you got something right or wrong. So these are the 3 steps: prepare, and that includes draw a picture. I find this to be a very, very important step. Necessary information and preliminary calculations. Solve, you use your equations and the tools that you know to find your answer. And assess, where once you have the answer, then you ask yourself, does this answer make sense? So drawing a picture, what do we do when we draw a picture? Well, you sketch your situation, establish coordinate system. This is very important. You define symbols, name things, and I'll tell you what that means in a minute, and list known information and things that you need to find. So those are the things that you want to get from that pictorial representation. So the visual overview, the picture could be a motion diagram, could be a graphical representation, a V versus T axis and X versus T axis. It could also include a sketch of what is happening. So let's look at some examples. Here is a rocket that is launched up, right? So this is a motion diagram that gives you an idea of how the motion is happening. This is a velocity versus time graph, and then this could give you an idea of what type of motion you have. And this I find to be a very useful picture here. You have your coordinate system, you have your origin, you have the rocket at 2 points, the initial and the final point, and then you've defined symbols here. You have a y initial, initial velocity, an initial time, and a final position, final velocity, and final time. And you also have a placeholder here for the acceleration. So you can go ahead and see which one of these symbols now you know and which ones you need to find. You can make a list. You know Y initial, you know V initial, you know T initial, so you know all these 3 here. You know the acceleration, so you know that guy there, and you know T final, you know this guy here. And this is what you want to find: Y final and V final. So you see from this graphical representation, and I know now what I need to do and what I need to find, and then I can go ahead in onto my next step, which is solve. So let's apply that to a little problem here. The same problem. You have a rocket that is launched straight up. This is the acceleration of the rocket, 18 meters per second square. After 150 seconds, right, that is about 2 minutes and a half, how fast is the rocket moving, and how far has it traveled? So pictorial representation, well, we could have a motion diagram, and this gives you a pretty good idea of what type of motion it is. You can see the velocity increasing. This is the acceleration. Then here we have actually the sketch. So we have the rocket at the initial position, the rocket at the final position. We have the acceleration, and we choose our coordinate system here. We name that y, and then we have our origin here at the bottom. That is a good choice. And now we can go ahead and start. We have the name for the symbols, and we can go ahead and start seeing what we know and what we need to find. We know y initial, we know the initial velocity, these both are 0, and we know the initial time because we can always set our stopwatch to 0. So we know those three numbers. We know these three things. We know the acceleration is 18 meters per second, and we also know the time from t initial to t final. So we know t final, which is 150 seconds. So this is what I know. And now this is what I need to find. I need to find the final velocity and the final position. I can find the final velocity because I have my three equations, so I can see what I know, what I need to find, and then I realize that this equation v final equals v initial plus acceleration times delta t is appropriate to find the final velocity, to find this value here. So I do that. V final equals v initial plus acceleration times delta t is equal to the initial velocity, which is 0, the acceleration here 18 meters per second square, and the time, and that gives me 2700 meters per second. That is the speed. So I know this number. Now I can find y initial, so I can use this other equation. It says y final is equal to y initial plus v initial times delta t plus 1/2 a delta t squared. So I know this guy is 0, I know this guy is 0, and I know this is 18 meters per second, so I get that y final is equal to 1/2 times 18 times delta t squared, which is 150 seconds squared. And then I can solve for y initial right there. And so that's how we solve problems. Those are the steps that we use to solve problems. So here again is the 3-step: prepare, solve, assess. Of those, prepare is the most important, and drawing this picture, having a visual overview of your problem, that is very important. So let's do one more problem here. We have a Boeing 747, and accelerates at 2.6 meters per second square, and so it needs to have a velocity of 7 meters per second to take off. So how much time will the plane, how much time does it take to reach this speed of 70 meters per second, and what is the minimum length of a runway that the plane needs? So here is our first step. All this here, this square here, that is prepare. So what we do there is we draw a picture, a sketch. We have initial, we have final, we label symbols here. We have the names for symbols. We have x initial, v initial, time initial. We have x final, v final, final time. We also have a name for the acceleration. So this is a good cartoon that helps you understand the problem. We also have a motion diagram here, and we can see that the velocity is increasing with the acceleration. So now we can go ahead and see from our picture what we know and what we need to find. We know the initial position, we know the initial time, we know the initial velocity, we know the acceleration, we know this guy, this guy, this guy. We also know the final velocity, which is 70 meters per second. So we want to find TF and we want to find XF. So that's preparing your problem. So now you know what you need to do. So now you can go on to your three equations and then see which one works. So we write our first equation, which is this one here, V final equals V initial plus acceleration times delta t. And then we can solve for delta t from that equation. We get that delta t is 26.9 seconds by solving this. So now I have solved for this guy. So now I need to find the minimum length. So for that, I'm going to use this equation, which is x final equals x initial plus v initial times delta t plus 1/2 a delta t squared. So I'm going to use that equation. I know x initial is 0, v initial is 0, and the rest is just this number here. And when I do that, I get 940 meters. So that's my problem, that's my solution. I have this and I have this, and now I assess my solution. Do they make sense, these two answers? Well, I mean, you've been to an airport, you've been to a plane, you know how long it takes for a plane takes about a minute, less than a minute to take off. So this is a reasonable number. Also, you have seen a runway and it's probably about a mile long. So this makes sense to be the minimum length that a plane needs. So, okay, so that's how we solve problems. So make sure you remember these three steps: prepare, solve, and assess. They are all important, and you should be able to, if you work with this recipe when you solve your problem, you should be okay with most problems.